Now let's look at this lemma. It is called as handshaking lemma. So it says that in any graph capital G of V comma E, which means if there is a graph G with V vertices and E edges, these are the vertex set and edge set, the sum of the degrees of the vertices is twice the number of edges. So look at this. Now if you count up if you add up all the degrees of the vertices, then that sum is going to be equal to twice the edges, twice the number of edges in the graph. So what I mean to say is, I'll take a simple example and explain you. Now if you see this, let's say there is a graph like this and there are three vertices A, B and C. Now what is the degree of A? Degree of A is 2 and degree of B is 2, and what is degree of C? 2. Now you sum up all the degrees, so it is 2 plus 2 plus 2. Now this is equal to twice the number of edges. So how many edges are there? 1, 2, 3. So 2 into 3, which means 6, isn't it? So how did we get this is, now if you assume that this is the sum of the degrees, right, in a graph, by adding a new edge to it, that edge is going to increase the degree of two vertices by 1, isn't it? Let us say I am adding a new edge like this. Now by adding this new edge, what happens is the total sum will be incremented by 2. One edge addition is going to increment this sum by 2. How? Because these two vertices are going to increase their degree by 1, isn't it? See, which means this one will be incremented by 1, this one will become 3, and this one will be incremented by 1, which means this one will become 3. Now the overall sum is going to be 3 plus 2 plus 2, right? So which is 8. That is why we got 2 into 4 also 8. So what does it mean? Every edge is actually contributing sum 2 to the total sum of degrees, right? So that is how we are getting this. Now every edge is contributing 2 to the total sum of degrees. That is why total sum of degrees of the vertices will be equal to 2 into the number of edges, right? Now you can apply this to any graph and you can check it. It need not be the simple graph. It will apply to even the multi-graphs as well. So for example, if you take this, you can check this. In this one, see, so how many edges and how many vertices? You can count them all. So let us say the degree of this vertex 5 is 3 and the degree of this vertex 2 is 1, 2, 3, 4, and the degree of this, okay, one more thing is, whenever you have a loop, you are supposed to count it twice. So a loop is going to provide a degree of 2 to that vertex, which means because of this loop we are going to get a degree 2, and because of the other edge I got a degree 1, therefore the total degree of this vertex is 5. Got it? And what about the degree of this vertex? 4. And what about the degree of this vertex? Because of this loop I get a degree 2 and then 2 more edges are there, so I get 2. So it is going to be 4, isn't it? So degree of 1 is going to be 4. Now what about this degree of 4? This degree of 4 is going to be 1, 2, 3. And what about the degree of 3? Now the degree of 3 is 1, 2, 3, 4, right? Now you sum them all up. So 4 plus 4 plus 4 plus 3 plus 3, isn't it? 4, 4, 4, 3, 3. So what is this? 12 plus 6, 18, right? Now if you observe this, since the degree sum is 18, how did we get this number 18? Because each edge might have contributed a 2 to this sum. Therefore the number of edges would have been half of it. Are you getting this? So therefore it is 9. Now even if you count the number of edges, you are supposed to get 9. So check this. Let's say this is E1, E2, E3, E4, E5, E6, E7, E8 and E9, right? And now why is it called a handshaking lemma is, let us say there are 3 people and each one is saying that I have participated in A handshakes, and I have participated in B handshakes, and I have participated in C handshakes. Now what will be the total number of handshakes? That will be A plus B plus C by 2. So how did I get this is, each handshake is going to provide let us say we have, okay, how to understand this one is, let us assume that there are three people and they are saying that I participated in A handshakes, B handshakes and C handshakes respectively. Now let us say I am going to add one more handshake. Then that one more handshake is going to increment the count of at least two people by one. Got it? Because if I have to add one more handshake, provided that a person is not going to shake his hand with himself, right? In that case, it is going to increment each one by 1 and 1. What does it mean? Every handshake is going to contribute a sum of 2 to the total number of handshakes each one is participating, right? Therefore, the total number of, if you count the number of handshakes in which each one is participating and if you sum them up, that will be equal to twice the number of handshakes, right? So it is exactly similar to the way how we discuss about the degrees of the vertices is equal to twice the number of edges, right? So how to see it in other way is, you can assume that there are three people, right? And if they have if they have participated in a handshake, just put a edge between them, right? Now every edge now will represent a handshake. And what about the degree of a node? The degree of a node or a degree of a vertex will represent the number of handshakes a person has participated in. Therefore, what will be the sum of the degrees? That will be equal to the sum of all the handshakes each one has participated in, right? And now if you see this, each handshake is going to contribute a sum of 2 to the total number of handshakes each one has participated. Got it? So that is why you can see the similarity between these two concepts, handshaking and the sum of degrees. Okay, now one more interesting property here is, now if you observe this, 2 into some number, whatever is the number of edges, this entire number is always going to be even. Getting this? See, whatever is the number of edges, the entire number is always going to be even. Now how will a number be even? See, let us assume that a number is represented as a sum of many numbers. Now when will that sum be even? When will this be even? See, if this is even, it means that sum of degrees is always even. When will this happen? It will happen only when all the numbers are even, or in case if you have odd numbers also, then the number of odd numbers in this should be even. Getting this? What I mean to say is, if all the numbers are even, I am going to get the number as even. Or if you have an even number, then you should an odd number, then there should be even number of odd numbers, which means there should be something like this. Then only you are going to make it as even number. Are you getting the logic? See, again, whatever is the number of edges, always 2 into number of edges is an even number. Now what is that saying? That the degree, sum of all degrees of the vertices is always even. Now when is that possible? When all the degrees are even, or there are even number of odd degrees. Got it? Then only we are going to get this sum as even, right? So if you want to see an example, you can see it this way. See, now if you have this, so 2 plus 2 plus 2, each degree is 2, 2, 2, right? It is even. Now if you have something like this, that's it. Okay, now what is it? 2 plus 2 plus 1 plus 1, 2 plus 2 plus 1 plus 1, right? Now you leave out these even numbers. If you look at these odd numbers, there should be even number of odd numbers, otherwise the total sum is not going to be an even number. Got it? And now let's say I have added one more this way. Now if you observe this, 1 plus 3 plus 2 plus 2. Again, if you see this, leave out these even numbers. Now look at these odd numbers. There will always be even number of odd numbers. Then only the total sum is going to be even, right? So that is the important thing that you should observe from here. So for any graph, always the sum of the degrees is going to be even, which means there are going to be all even numbers as the degrees, or in case if you have any odd number, then there will be even number of nodes with odd degree. That is the point. Number of odd degree vertices are even, right? And also based on the degree of the vertices, graphs can be classified into two types. One is odd graphs, other is even graphs. If all the degrees is even, then the graph is called as even graph. If all the degrees, or if some of the degrees are odd, Okay, so that we cannot call it with any name. If all the degrees are even, we can call that graph as even. So see this, now 2, 2, 2, 2. Since all the degrees are even, we can call this graph as even graph. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.